We have discussed electroplating. Now we are supposed to discuss electroless plating. What is electroless plating? As the name indicates, electroless. Electro means current, less means no current, right? Electroless. So plating without electricity is called as electroless plating. So let us see what do you mean by electroless plating, what are the differences between electroplating and electroless plating. Okay, so the process of depositing a metal on the surface of catalytically active substrate without using electricity and using a reducing agent is called as electroless plating. So as I told, without using electricity, how to deposit a metal on the surface of a substrate? So for that, you're going to use a reducing agent. So if you want to, for instance, I want to deposit copper on the surface of a substrate. There is no anode here. So I'm supposed to deposit a copper on surface of this. So I'm going to dip this in electrolyte. To that I'm going to add copper sulfate, but copper should get deposited over here, right? So what I'm going to do, I'm going to add a reducing agent. So what is the purpose of reducing agent? Reducing agent undergoes oxidation first. Reducing agent undergoes oxidation, self-oxidation presence of a base, and it liberates electrons. So this electrons, what is reducing? These electrons will be used up by Cu2 plus ions to undergo reduction. So we're going to add a reducing agent. Reducing agent undergoes oxidation. By undergoing oxidation, it will reduce the opponent. What is reducing agent? Reducing agent undergoes oxidation. By undergoing oxidation, it will reduce the opponent. So it reduces the opponent on the surface of the substrate. So the main motto of this, the substrate for this is the reducing agent. Without reducing agent, redox reactions will not occur and plating will not occur. Okay, so the electrolysis example, electrolysis plating of copper, nickel, etc. We'll see how this is carried out in our next discussion. So we're going to take, as shown in the diagram over here, we're going to take a substrate catalytically active surface. Why it should be activated? Because the reduction reaction should take place only on the surface of the substrate. It should not take place in the electrolyte solution. So because of that, we're going to take a catalytically active substrate. We're going to add reducing agent. After adding the reducing agent, what will happen? The reduction reaction takes place only on the surface of the metal or substrate. So there is a small animated video which shows how electrolysis plating is carried out. So let us see how it is done. So here electrolysis plating can be done for plastic, glass, ceramic, anything. Commonly referred to as POP. So usually electroplating can be done only for metals. Why? Because metals are conductor. We are connecting it for a DC power source. But here electrolysis plating can be done for glass, plastic, any non-conductors and the conductors too, and small minute particles. Okay, because it is dipped in a solution and reducing agent is added. Whereas electroplating is done only for conductors because it's connected to a DC power supply. Electrolysis can be done for anything. When for plastic, electrolysis plating can be done, for ceramic it can be done, for glass it can be done, anything, any non-conductors or insulators. Let's just have a look how electrolysis plating is done.
Its characteristics for plastic parts. Attached to plating racks, bare parts are ready to be treated in a sequence of different chemicals. The first step of the sequence consists of cleaning residue from the plastic surface.
So
before processing, the average roughness of plastic is about 25 nanometers. After cleaning, the parts are immersed for 5 to 15 minutes in an etching solution to promote adhesion of the plated metal to the plastic. Etches are chromic and sulfuric acid mixtures used at 68 degrees Celsius. The etching process is designed to increase the micro roughness of the plastic surface. The topography is roughened to 240 nanometers by creating pores in the plastic, as shown in the SEM photomicrograph. These pores ensure good mechanical adhesion of the different layers of copper, nickel, and chromium deposited later in the process. After etching, parts are thoroughly rinsed with water, then neutralized in a chemical step that reduces hexavalent chromium to trivalent chromium, since traces of the former will poison the catalytic process. Catalyzing the plastic with the controlled adsorption of palladium and tin colloidal particles in the micropores is critical for making the surface conductive. The next process is referred to as accelerating the surface, where a chemical reaction takes place to oxidize tin plus 2 ions to tin plus 4, and palladium ions are deposited on the surface as metallic palladium. After acceleration, The surface is ready for a thin layer of a conductive metal to deposit on the palladium catalyzed surface. This occurs from an electroless nickel process step, which deposits a thin, dense nickel phosphorus alloy. The nickel alloy layer thickness deposited from the electroless nickel ranges from 0.2 to 0.4 microns, resulting in the plastic parts becoming conductive, which is very important for the deposition of the copper, nickel, and chromium electroplating sequence. After creating the initial conductive layer
There
with
are
the
no
electroless
anodes
nickel,
here. You can
racks
see.
of parts are processed through an immersion
So
copper
plastic
or nickel
it
solution
is counted.
to
So
further
it looks
improve
like
their
copper, right?
conductivity.
But copper is plated here. It is deposited over here.
Next, a 20 micron thickness layer of copper deposited from an acid copper electrolyte provides leveling of the etched plastic surface, while also producing a bright, smooth deposit. This layer also provides ductility between the plastic and other plated layers, which is important to improve the thermal shock resistance while also minimizing the formation of cracks when the plated part is in service. A bright nickel deposit from 5 to 7 microns provides protection of the copper layer, gives a final bright aspect, and supports the chromium layer. In automotive industry POP applications, multiple layers of different types of nickel deposits are utilized to further increase the corrosion resistance of the plated plastic. The final chromium layer deposit of 0.1 to 0.2 microns thickness
Copper,
provides a
nickel,
final
finally
corrosion and
chromium
anti-tarnishing
for decorative
protective layer
surface.
while
But
giving the
the
surface a
base
bright
is
and
plastic.
decorative aspect. It also provides good shock and abrasion wear resistance. After these simple sequences of process steps, the non-conductive plastic parts are now visually more appealing, with layers of copper, nickel, and chromium that also provide important functional characteristics. Parts are now rinsed, dried, and carefully examined before being shipped to any final assembly for the final application. Technicians will check surfaces for any defects, including pits, stains, hazes, misplating, or cracks, to verify that good quality product is the result for the final customer. The next time you see a plastic perfume bottle, a plastic plumbing fixture, or automotive interior or exterior trim piece, you can now have a better appreciation of what makes that possible.
Got it? Let us see the advantages of electroless plating. So in the electroless plating, use of electricity is completely eliminated. Semiconductors, insulators, glass, plastic, ceramic, you name this, that can be plated. That is the beauty of electroless plating. So small and minute parts of machinery can also be plated uniformly and no levelers are required. Electroless bar solution have better throwing power. So electroless coatings are harder. So these are the advantages of electroless plating. So electroplating, let us see the differences between electroplating and electroless plating. So the driving force behind the electroplating is current, whereas driving force behind electroless plating is the autocatalytic redox reaction. The driving force behind the electroplating, anode used in electroplating is separate anodes are used, whereas there are no anodes in electroless plating. There is only one substrate is used. So the cathode is object to be plated. So here in electroless plating, there is no anode or cathode. The substrate itself will act as cathode. The reducing agent used, there are no reducing agent itself. Since in electroplating or connecting to DC supply, electrons itself will act as reducing agent. In electroless plating, chemical agents. So for example, for your copper electrolyte splitting, we're going to use formaldehyde. So chemical substances are used as reducing agent, whereas in electroplating, we're going to use electrons. Throwing power is less in case of electroplating, whereas it's very good, very high in electrolyte plating. So electroplating can be applied only for conductors because it should be anode and cathode is applying current. When you're applying current, only conductors can allow current to pass, right? Electrolyte plating can be used for conductors, non-conductors. Non-conductors cover large objects. So from your pen, bottle, ceramic, tiles, everything it will cover. Okay. So let us see the applications. So the plastic can be plated, semiconductors, non-conductors can also be plated, small machinery parts which cannot be plated using your electroplating can also be coated. Through hole connections can be done in your PCB. So the major application of electrolysis plating is in your PCB, that is your printed circuit board. So let us see that printed circuit board how. Okay, thank you. Let us discuss electrolysis plating of nickel in our next discussion. Thank you.